Hello everyone. We are Team SnapQuest. Our project is Advanced Search on Photo Gallery. Our project mission is to reduce the time search for the relevant images in our phone gallery. So it enables the text query search with the content of the images and returns the relevant images in no time. Currently, if we see, there are no available tools in the market which searches your images with multi-keyword. So while doing this project, we have faced few challenges related to caption generation, data collection, and search rank algorithm and dynamic data. Coming to technical overview, I'll go over this architecture we have where we have all the technical details. So we have used here our Django framework and we have created an user interface where user can input text query for the image search and also choose between the search type options which we are providing and also add an image in the data set which is currently not existing. So suppose that the user go with the text query search. If the query is given, then it goes to the search engine and it searches the that query into our database and renders the image output. And in the second option, if it go user has input the image upload option, then the image is uploaded and the ML model is triggered in the background and it creates the caption for that image and put it into our database, which will be used in future for the query search. So this is the whole idea. Come to the search type. Uh, okay, before that, I can go little deep into our ML model. ML model which we have used here is the blip model. And how it works is suppose if you input this image, ML model in the backend triggers an caption like this, where it tries to capture all the details and the feature in the images. And what are the search options we have provided is like which maps query to the images, like cosine similarity, which try to find the maximum similarity between the query and images and renders the results accordingly. And we have also used positional index where if your query has like keywords aligned like similar to the caption of the image has been generated, then it renders those kind of images and comes to the DESM, which is a neural network based similarity model. This also we have implemented. So let's talk about the major features and the results of our project. The feature is we enables the multi-keyword query search for the images. And the additional feature is the user can upload a image which is currently not existing into the database and can do a query search for that image. So to do the performance evaluation, I'll take you to the live demo. This is our UI where suppose I want to search for an image where a is man driving a red car. So I have chosen an option of cosine. Let's see the output for that. So as we can see, the first five option results are showing very relevant images. We have more options also. So we could see that in our database, we have more than five images which are relevant to our query. So we are here rendering our top 10 results. Let's see the results in case of the DESM search. In DSM search, we could see that the the first ranked image is not very much similar to our query. We have searched for the red car, which is on the second rank. So DSM is kind of not behaving or performing as well as cosine. Let's see how the position index is performing. Okay, so here we have one result, but it's a exact match to our query. But as we know that in our database, we have more than one images, but positional is still rendering just one image. So it could be because the positional look for a keyword aligned in the caption, how the ML has been generated. So it's just rendering just one images, not the other images. While the cosine take the each terms independently and look for that. But in some small queries, we have seen that the positioner works fine. Suppose that if I want to look for a photo of the green sweater, so I could see that, okay, the results are very much we wanted. Here is the green sweater photos and no other images are rendered here. Let's see how the cosine is behaving in this case. So we could see that, okay, the first ranked image is very good, but the second image has the green color leaf and the woman is wearing a sweater, but it shouldn't be ranked second. Whereas the third image is very much matching to our query, but it is still ranked three, not second. So cosine is taking each keywords independently and giving us the results like that. So I could see that the in some scenario positional is working fine for the small query search, and in some scenario cosine is working fine. Our model also supports multi-key as it supports the multi-keyword search. So here the number of keywords could be more than 5 or up to 10 or even more than that. I want to search for some very specific image where a man in black shirt, black pant, holding a black bag. So so I know the feature of the images. So I am querying that specific image. Let's see how does it perform. So we could see that the very first image is exactly matches to our query, whatever I have given. The man in the black shirt, black pant, holding a black bag. So I'll say our model is behaving very fine. And okay, so now let's move to our second feature where we enables the upload of the image. Let's suppose that so I'll just show you. Currently, we don't have any image related to Jabra. So if I search, it say okay, no results found. So I want to upload an image of Jabra and later I want to search for that. So see, now I'm uploading an image. The moment I uh, push this upload image button, our ML model gets triggered in the background. I'll show you and starts working on that and trying to create a caption for this and put it into the data set. As it has completed, we'll see the results. So now we'll search for Zebra and let's see the output. Yeah. So the uploaded image is coming into the results. So yeah, this is how the upload image is working fine. Moving on to the future scope of this project, we have think of like the performance can be improved in case of the dynamic dataset upload, and also we have worked on image addition but not deletion, which can be done in future. And also this search can be extended to the video search. That will be a very good feature. So just for references, like we have used Blip ML model and we have given a references of that code and our project Git repo also. If you have any questions, you can reach out to any of us. We are the four members who have worked on this project, Ashish, Harman, myself, and Tanushree. Thank you for listening.